Imagine waking up at 3 in the morning. Your phone is blowing up.
Oh, the worst feeling.
Right. Your servers are buckling under pressure. And your production code base is actively double charging your most important customers. Beat. Every single second that ticks by is costing your company thousands of dollars.
It's a total nightmare scenario.
It really is. Today, we are looking at what happens when OpenAI and Anthropic are dropped directly into that exact terrifying situation.
And that's where the marketing hype usually goes to die. I mean, it's easy to look good in a carefully curated press release, but it's a completely different story when the system is actually on fire.
Welcome to the deep dive. We have a very clear mission today. We are cutting through the endless noise of the AI arms race.
There's so much noise right now.
Exactly. So we are looking closely at Opus 5, Fable 5, and GPT-5.6 Sol. We want to figure out which model is actually ready for messy, real-world human workflows.
Now, Fable 5 is definitely a serious contender in this generation's broader race, but today we're keeping our focus strictly on the direct, head-to-head data we have in front of us.
Right.
We're putting Opus 5 and GPT 5.6 Sol through a brutal, uncompromising gauntlet.
We're running them through 3 highly specific tests. First, we are looking at deep back-end coding. Then, we are testing front-end web design.
And finally, we're diving into human audience research.
We are essentially testing cold logic, human aesthetics, and psychological empathy. Let's start with the invisible backbone of software: pure logic and problem solving.
We need to see if these models can step in and fix a deeply broken system, and crucially, without making things worse.
This feels like the ultimate crucible for an AI. Writing a brand new Python script from scratch is a fun party trick.
Yeah, any model can do that now.
But debugging someone else's ancient, messy production code, that requires an entirely different level of contextual understanding.
It absolutely does. The stakes are incredibly high here. For this test, both models were handed a massive, live production code base. They were given a very brief description of a bug, along with the expected behavior. They had to find the root cause, write the fix, and test it thoroughly.
And here is the real catch. They couldn't break any existing features while fixing the new one.
Which happens all the time.
It's kind of like trying to change a tire while the car is driving down the highway at 80 miles an hour.
Right. And they also had a very strict stopping condition. They could only declare the job finished when all the automated tests passed green.
Or, if a test failed, they had to clearly explain why the failure was actually expected behavior.
I have to offer a vulnerable admission here.
Go for it.
Even after years of looking at code, I still wrestle with tracking down race conditions myself.
Yeah.
And it's just one of the most frustrating things a developer can face.
Oh, it drives even senior engineers completely crazy. The bugs hiding in this specific code base were particularly nasty.
What were they looking for exactly?
Well, there were 3 distinct hidden issues they had to uncover. First, a race condition in the idempotency check.
Okay.
Second, a payment state being saved far too late in the transaction flow. And third, a tiny, seemingly invisible 1-cent rounding error. Let's pause for a second. We should define a couple of these technical concepts for you, just so we are all on the same page. What exactly is a race condition in this context?
Think of it like 2 people buying the same ticket. The system processes both.
Perfect. That makes perfect sense. And what about idempotency?
Pressing an elevator button 10 times only calls one single elevator.
Okay, I love that analogy. You want the system to only charge the credit card once, even if the user frantically clicks the checkout button 5 times in a row.
Exactly.
So looking at the data, how did our 2 models actually perform when thrown into this fire?
The results were genuinely surprising. Both models successfully tracked down all 3 hidden problems.
Wow.
Yeah, they both correctly diagnosed that 2 rapid simultaneous requests could bypass the database index entirely. That's what was causing that awful double charge scenario.
So how did they try to fix it? Opus 5 tackled the problem first, right?
It did. It decided to suggest using an idempotency record as a state machine. It went in and added a unique database constraint.
Along with what is called an atomic claim. Let's unpack this. Why choose a state machine?
A state machine is a very traditional, highly structured way to solve this. It's like putting a very strict bouncer at the door of your database.
Checking everyone's ID.
Right. The bouncer checks every single ID card before letting the transaction through. It works, and it prevents multiple requests from processing simultaneously.
Opus 5 also caught the late payment state issue. It reorganized the code to save the payment ID much earlier in the flow.
Which is smart.
Yeah, that way, if the whole system crashed and had to retry, it wouldn't accidentally double charge the customer.
It provided a very detailed, theoretically sound migration patch. But here's where the rubber meets the road.
Uh-oh.
Opus 5 was noticeably slower to generate the fix. And when the code was actually executed, it had lower pass rates on the test suite.
Because the state machine approach was a bit too rigid for this specific architecture?
Exactly. It was over-engineered.
This is where GPT-5.6 Sol took a fundamentally different approach. Sol didn't try to build a massive bouncer at the database door.
No, it didn't.
Instead, Sol proposed generating a stable idempotency key and passing it directly to the external payment provider.
This is a brilliant architectural choice. Instead of managing all that chaotic state internally, Sol essentially handed the problem off to Stripe or PayPal.
It told the payment provider, hey, here's a unique token for this specific transaction. If you see this token again, ignore it.
It's so much more elegant. It handled the payment recovery incredibly gracefully. By saving the payment result right away, before even attempting to create the order in the database, it eliminated the risk of data mismatch.
Sol covered the request conflicts beautifully. And because its solution was lighter, it finished the task significantly faster than Opus 5.
And it delivered much better test results overall. Sol decisively wins this first round.
That brings up a crucial point about system architecture and emergency response. Beat, why does the sheer speed of an AI's bug fix matter so much in a production environment?
Because every single second counts during a live outage. You need minimal downtime to stop system failures from cascading.
So faster fixes mean less downtime, keeping the whole system from collapsing.
Speed is literally safety when servers are crashing.
So Bell absolutely dominates the rigid objective world of backend logic, but code is just math at the end of the day.
Right.
What happens when we force an AI to deal with something highly subjective? Let's move from the backend to the visual front end.
This is a fascinating pivot. We want to see how these models handle aesthetics, spacing, and visual hierarchy.
Can they build something that actually feels good to a human user?
The task here was to design and code a complete landing page. Just one cohesive page for a fictional business called the North Star AI Consultant Program.
But the constraints they were placed under were absolutely brutal.
Yeah, they really were.
They had to use pure, naked HTML, CSS, and JavaScript. No external libraries allowed, no React components, no Tailwind shortcuts.
Just raw, fundamental code.
2-sec silence.
Whoa.
Imagine generating a complete, premium, zero-dependency website in one breath.
It is genuinely staggering to think about. We rely so heavily on modern frameworks today. Asking an AI to build without them is like asking a chef to bake a wedding cake, but first they have to go mill their own flour from scratch.
The prompt also demanded a very modern, premium visual identity. We are talking deep, dark navy backgrounds, electric blue and cyan accents to give it that cutting-edge tech feel.
They even had to generate an original inline SVG compass logo. The page needed smooth scrolling, interactive hover states on the buttons.
And it had to be fully responsive across mobile and desktop screens. If they're forced to use pure HTML and CSS, they can't rely on prepackaged visual templates to save them.
Nope. They have to show their raw architectural design skills.
So without those crutches, how did GPT 5.6 Sol's visual identity hold up?
Well, Sol actually delivered a very strong conceptual identity. The typography was bold, the large headline and the generated compass design gave the North Star brand some real character.
The color palette stayed consistent with the prompt too.
It did. But when you actually looked at the rendered page, it struggled significantly with the layout.
It really did. Solal just didn't understand the invisible glue of web design.
Yeah.
Which is negative space.
Right. It left massive, gaping, empty spaces between the sections.
And bad spacing completely breaks the visual hierarchy. It makes the user feel lost on the page.
It felt very unpolished. Kind of like a rough wireframe that had colors slapped onto it. You'd have to go in and manually adjust the CSS everywhere just to make it feel tight and professional.
No, Opus 5 took the exact same brief. And looking at the source files, Opus 5 absolutely nailed it.
It was a night and day difference. Opus 5 created a beautifully balanced, incredibly clean layout.
The spacing was tight, the typography scales perfectly when you drag the browser window down to mobile size.
It also made a brilliant, completely unprompted design choice. When the user scrolls down to the problem section of the page, Opus 5 seamlessly swaps the background from dark navy to a clean, light color.
That rests the user's eyes. It creates immediate, sharp visual contrast.
Exactly. It signals to the brain that we are entering a new conceptual space. That is a very human, empathetic design choice.
And the inline SVG compass theme Opus 5 created was striking. It looked like a real logo, not just a random collection of geometric shapes.
Opus 5 definitively wins this round. It only required one tiny manual edit because it slightly over-explained its own design in the text.
It's fascinating to see this divergence. Sol wins pure logic. Opus wins human aesthetics. Beat, beat. But this strict design test makes me wonder something deeper about our testing methods. Why force an AI to build in pure naked HTML and CSS instead of modern frameworks?
It forces the AI to show fundamental structural understanding without relying on pre-built crutches.
Pure code reveals the model's true grasp of raw design fundamentals.
You really can't fake good design when you're writing raw CSS. Mid-roll sponsor, read placeholder.
We have seen these models write complex back-end logic. We have seen them paint a beautiful, responsive user interface.
But can they actually understand the messy, contradictory reality of human psychology?
That is the ultimate frontier for AI. Deep market research requires real empathy. You have to read between the lines and recognize behavioral patterns.
The third and final test focused on researching the actual human audience for this fictional North Star program. We needed to know what these people actually want.
The target demographic was very specific. These are professionals who know how to use AI tools, but they have no idea what specific service to package and sell to clients.
They have the skills, but lack the business model.
The models were restricted to using only recent public web sources. They had to scour Reddit, LinkedIn, and professional niche forums.
And we only allowed data from the last 18 months to ensure relevance. There was also a very strict guardrail in place.
Right. No hallucinated quotes, no fake survey data whatsoever.
If they made a claim, they had to back it up with real online sentiment.
I have to push back on this premise just slightly. Can an AI really understand deep audience hesitation just by scraping a few professional forums? Beat. It's like trying to understand the ocean by reading a glass of water.
That's a totally valid critique. Human hesitation is deeply subtle. It's usually what people don't say that matters most.
Exactly.
But on the flip side, anonymous online forums are where people go to vent their rawest frustrations. They ask highly specific, desperate questions on Reddit that they would never ask their boss.
That's true.
It's a goldmine of raw, unfiltered data if you know how to parse it.
That is a fair point. So how did Opus 5 handle this massive ocean of unstructured venting?
Opus 5 did surprisingly well right out of the gate. It pulled real, actionable data from freelance marketplaces like Fiverr, Upwork, and JigRadar to see what AI services were actually selling.
It also did something I found incredibly smart. Opus 5 explicitly noted in its report that major platforms like Reddit and LinkedIn actively block direct scraping access now.
That shows a level of true self-awareness. The AI realized it was hitting a paywall or a scraper block. It acknowledged that some of its evidence had to be secondary.
It understood the limitations of its own visibility. It successfully mapped the main problem. People know how to prompt an AI, but they can't convince a traditional business to pay them a retainer for it.
Right. The friction is in the sales packaging, not the tech. Opus 5 provided a solid baseline, but GPT-5.6 Sol completely changed the game here.
Sol didn't just summarize data. It delivered an absolute masterclass in report structure and epistemological rigor.
Let's get into the mechanics of that. What made Sol's structural approach so much more valuable to a user?
So explicitly separated its findings. It created a rigid boundary between direct evidence it pulled from the web and its own analytical inferences.
It also clearly isolated weak ideas that required further human research before acting on them.
It didn't just dump a wall of text and facts onto the user. It organized the chaos into a readable narrative.
Exactly. Sol built a brilliant, actionable table linking the common audience problems directly to potential business impacts. But here is the crowning achievement. Sol assigned explicit confidence levels to every single finding in the report.
High confidence versus low confidence. That is brilliant. It's kind of like a detective mapping out a case board.
Yeah, and the high confidence claims are like physical DNA evidence. The low confidence claims are like a sketchy tip from an anonymous informant. Sol clearly labeled which was which.
So wins this round effortlessly. It makes the final report instantly trustworthy. You can scan down the page and know exactly what is a rock-solid fact and what is just an educated guess.
It's a massive time saver.
That structural choice is fascinating to me. How do explicit confidence levels change our relationship with AI outputs?
It turns the AI from a know-it-all oracle into a cautious, reliable research assistant.
Labels build trust by clearly separating cold, hard facts from educated guesses.
It completely neutralizes the danger of invisible hallucinations. You aren't guessing if the AI is lying anymore.
Let's pull back from the micro details for our big idea recap. We have put these models through a brutal gauntlet. We are looking at the final scorecard here.
Based on the raw data, GPT 5.6 Sol take the overall crown, winning 2 out of the 3 tests.
Sol is clearly the heavy lifter of this generation. It dominates rigid back-end coding. It crushes structured, evidence-based research.
It organizes chaotic information, like stacking Lego blocks of data perfectly into place.
But we cannot discount Opus 5. It is the undisputed champion of visual layout and human feel.
It understands front-end design, spatial awareness, and aesthetics on a much deeper, more empathetic level.
So what does this actually mean for you listening right now? We need to connect this abstract data back to your daily workflow.
If you're a back-end engineer tracking down complex database bugs or trying to optimize server load, you need to use Sol.
If you're a marketer or a product manager doing deep audience research and you need rigorous, clearly labeled data, Sol is absolutely your tool.
But if you're a front-end developer, if you're a web designer trying to build landing pages that actually convert users, Opus 5 might fit perfectly into your daily workflow.
It's no longer about finding the smartest AI. It's about choosing the exact right tool for the specific job in front of you. Beat. And this leaves me with a final, somewhat provocative thought to chew on.
I always love these. Let's hear where your head is at.
We're witnessing this incredible organic specialization happening right before our eyes. We didn't explicitly train Opus 5 to be an artist, but it naturally leans toward aesthetics.
Right.
We didn't tell Sol to be a detective, but it naturally leans toward rigorous, compartmentalized logic.
They're developing distinct, almost human-like professional personalities.
Exactly. So what does the future of human work actually look like in 5 years? Will we ever get one perfect, monolithic, generalist AI that can do everything flawlessly?
Probably not.
Or is the future of work entirely about managing an Ocean's 11-style team of highly specialized AIs, assigning each to their natural strengths?
That's a wild thought, a totally different model for every single microtask in your day.
Right. You become the human director, you give the math to Sol, and you hand the paintbrush to Opus.
It requires a completely different management skill set from the human operator. You have to deeply understand your AI team's blind spots.
I want you to take a hard look at your own daily tasks today. Look closely at your specific workflow. Which model's natural organic strengths align perfectly with the bottlenecks slowing down your work right now?
It's time to stop looking for the one perfect tool that does it all. You need to start finding the right specialist.
The smartest operators aren't looking for a magic bullet. They are already busy building their crew. Beat. Thanks for joining us on the Deep Dive.